In this video, we're going to go over the distance and midpoint between 2 points on the coordinate plane. So the distance formula is one that we've used many times before. It's basically the Pythagorean theorem, but with the hypotenuse already solved for. So let's try using the distance formula, which is given here in the box, to find the distance between this point A and this point B. So when we set this up, we're going to look for the distance, which we can call d, and the outside of the formula has a great big square root. And then in the first parentheses, we are subtracting the first x value minus the second x value, remembering that x is the first number in each of these parentheses. And it actually doesn't matter if you do the first minus the second or the second minus the first, as long as you're consistent with which one you pick. So if we do the second coordinate, let's say the 3, minus the first coordinate, that would be a -2, being really sure to show the minus and the negative. And then there's a squared outside of those parentheses, plus, open up another set of parentheses, and this time it's a y value minus a y value, making sure you go in the same order as whatever order you just chose for the x's. So this time we have to do the second one minus the first one, because that's the order I picked for x's. So just make sure you're really clear about which is x and which is y in each pair. So you're subtracting x's in the first parentheses and y in the second. Then it's a matter of simplifying what's in each of the parentheses. Going by order of operations, we want to clean up what's inside the parentheses. 3 minus -2 is 5. I'm keeping it in parentheses. 4 minus 1 is 3, keeping it in parentheses. It's especially important if it comes out negative. Then we square both, so 5 squared and 3 squared. Very important that you square them rather than get rid of the squareds, because that doesn't work. And then 25 plus 9, which would be 34. And then it's underneath the radical sign, the root. So you see if there's a way to simplify your square root, which if it's the square root of 34, nothing goes into 34. That is a perfect square. So we can just box that and say that's the distance between A and B. The way we would have done this back when we first practiced finding distance between 2 points would have been on the coordinate plane. So as the cartoon says on the side, the distance formula saves us from having to graph the points on the coordinate plane every single time we want to find a distance. Just to illustrate what that looks like, these are the same 2 points A and B that we just found the distance of on the previous slide. And so one way you could have found the distance between them is to graph point B, -2, 1, and graph point A, and then try to create the line segment between them, which is slanted, so you cannot count that distance, but then create a right triangle that has that as the hypotenuse, so you can use a squared plus b squared equals c squared. So you would use as a and b the two horizontal or vertical distances that you can count. And in this case, a would be 3 and b would be 5. And then you would end up doing a squared plus b squared equals c squared, where a and b are the 3 and the 5. And those should look familiar from when we just did it by the distance formula, because it's the 9 and the 25 that we ended up adding together in the end. So 34 equals c squared, and the square root of 34 equals c. So this method still works and is valid, but the distance formula saves us from having to draw a graph every time we want to find a distance, and that's especially helpful if we don't have a graph that's neat to use, or if the numbers are very big. One thing, well, you can do many things with the distance formula. One thing you can do is talk about triangles on the coordinate plane, and use the distance formula to determine if the triangle is equilateral, which would be all 3 sides equal, isosceles, which is, so this is 3 sides equal, isosceles is 2 sides equal, or scalene, which is a word that means none of the sides are equal in length. So if you had triangle ABC and you wanted to not graph it, but determine whether it's an equilateral, isosceles, or scalene triangle, you could find the length of AB, the length of BC, and the length of AC, and determine if any of them are the same. So rather than calling them D, D, and D for a distance, because it wouldn't be clear to me which distance I was finding, I'm going to call it AB, BC, and AC, which means the distance between A and B, distance between B and C, and so on. Each one of them is going to be a big square root. And in each one of them, I just need to be careful about which numbers I am using. So to find AB, the length of this line segment, I'm going to use this as my x and x, because that's from point A and B. So 2 minus 1 squared, and then I'll use the y's from those same coordinates, so 5 minus 2 squared. For BC, I would use the points D and C, making sure that those are the x and y values I'm using. So 4 minus 2 and 1 minus 5. And then for AC, I would be using the coordinates A and C. So 4 minus 1 and 1 minus 2. And then going on to simplify each of these to determine if any of them come out the same. So the first one is going to be the square root of 1 squared plus 3 squared, which is the square root of 10. Next one comes out to the square root of 2 squared plus, and here's one where it comes out negative. Really important that you keep it in parentheses, because when you square it, a negative 4 times a negative 4 is a positive 16. So this ends up being the square root of 4 plus 16. That can simplify. And then AC. So the square root of 3 squared plus negative 1 squared, which is 9 plus positive 1, so the square root of 10. So I see that because I have two sides the same, I can conclude that this is an isosceles triangle. And then it asks me in part B to determine if it's a right triangle or not. So to determine if a triangle is right-angled, remember we use Pythagorean theorem, and check if it works. We need to first decide which is the longest of the three sides. So a root 10, a root 20, and a root 10. It's clear that the root 20 is going to be the longest of the three. So when I check a squared plus b squared equals c squared, I need to make sure I'm putting the root 20 as the c and the root 10s as the a and the b. So I do root 10 squared, which is 10, plus root 10 squared, which is 10, plus root 20 squared, which is 20. And indeed, 10 plus 10 is 20. So this is a right-angled triangle. So it's an isosceles right triangle. Okay. And then we move into the second half of this lesson, which is about midpoints. This is just a definition. The midpoint of a line segment is the point that lies midway between A and B. And as you can see from this picture, there's a dash here and a dash here to show that it's equal in length on either side of it. So A is going to be some point xy, B is going to be some point xy, and the midpoint is also going to be some point xy that's halfway between A and B's coordinates. There is also a formula for getting midpoint, and it's basically just the average of the x's and the average of the y values. When I say average, I'm talking about, add them together and divide by 2. It's like the average x and y. That's how you get a midpoint. So you'll add together the two x coordinates and divide by 2. Add together the two y coordinates and divide by 2, and you'll have your midpoint coordinates. So here to find the midpoint of AB, this means segment in our book. If you see this square bracket around something, that means the segment AB. So the midpoint of that segment is what we're asked to find, and they tell us what A is and they tell us what B is. So in order to find the midpoint, which we could call M, or they may ask you to assign a different letter to it in the problem. Here they don't. I'm just going to call it M. Can be found by doing the addition of the two x coordinates, again making sure you're very clear about what x1 and x2 are, divided by 2, comma, because remember we're looking for coordinates, the addition of the two y values, divided by 2. So the average x, average y. It's a simple procedure. If you get a fraction, just leave it as a fraction over 2. 3 plus 7 is 10, divided by 2 is 5. So we would say the coordinates of the midpoint are 3 over 2, comma 5. And then only one other slightly trickier version of that question would be, what if they give us M, which is the midpoint? Okay, so they've given us M, and they've given us A, which is one of the endpoints, and asked us to find B, which would be the other endpoint. So let me just show a visual of this that's not drawn to scale at all. But this is basically like they're giving us A, they're not giving us B, and they are giving us the coordinates of M, the midpoints. They're giving us the middle, and they're asking us to find B. So one way to do it is just by common sense thinking, all right, so if A goes from 1 to 4, then as it goes to m, then this one's going to have to go up by the same amount. So you're thinking from 1 to get to 4, I have to go up by 3. So I must have to go up by 3 again. And therefore, this coordinate is going to start with a 7. So this is one way to do it, and I'll show another way if this way is not working for you. Same thing with the y's. You're thinking, right, if a 3 became a negative 2, that's like going down 5. So I must have to go down 5 more. And so that would be negative 7. So the coordinates of B are going to be positive 7 comma negative 7. There's an algebraic way to show this using the formula if you prefer that, which would be the coordinates of M are 4, negative 2. And remember that that is the first x value plus the second x value divided by 2. First y, second y divided by 2. And in each case, I know the first x and I know the first y because I was given coordinate A is 1, 3. So I could rewrite this as 1 plus the other x divided by 2 and 3 plus the other y divided by 2. And I know that it's supposed to come out to 4 for the x coordinate and negative 2 for the y coordinate. And then these are each equations that you can solve. So basically split your board here. This equation on the left, you would multiply by the 2. So 8 would equal 1 plus x. And subtract the 1 from both sides. So 7 must be your x coordinate, which is exactly what we had set up there. And then in this case, again, you'll multiply by the 2. 3 plus y2 is equal to negative 4. And subtract 3 from both sides. And you'll get that y is equal to negative 7, which is again what we know. So now we have b is 7, negative 7. So you can get there by the jumping method or by the algebraic method. And that is all.